The last words are the best for me, so no matter what you do, but the better thing is to be kind and a good person. So I try hard for do that. Okay, and thank you for the organizers to the organizers to invite me to that opportunity to share knowledge, to share the little knowledge that I have around these old fields. Because you know, there is, if you have knowledge about a lot of things, you don't have deep knowledge about one thing. So what happens to me, okay? So I will just give an overview and trying to also to catch the spirit and the view in some way, in a humble way, as Ramon Margalef did, which he was a naturalist. I am not a naturalist, but I take their lead and their ideas, and I studied also during my PhD and after my PhD his inspiration. So for me it is an inspiration all the days that I am doing research. So let's go for the talk. And I just split the talk in 3 parts. I will set up a problem, then a solution, and finally the issues with the solution, okay? So I will just go for the main problem that we have currently, which is what is called global change, but I don't like so much that global change name, because it simplifies too much the problem. So I just split up the problem in three parts. One is the climate, the other is ecosystems, and the other is the energy needs, social energy needs. And there are 3 crises on each of these fields. Then I will go to the solution, what the European Commission is doing in research and in funding to deal with that crisis, mainly the climate crisis, and laterally and the ecosystem crisis. But it's not recently, it's the EU, the Commission, has been suddenly aware that there will be a problem with the energy too. And finally, what issues has that solution? And then I will go for the renewables implementation to make the renewable energy transition. What are the issues with the renewables? And finally, how that deployment of renewables will affect to marine ecosystems. So going for the first part, I don't say anything that is a review. So I don't say anything new for you. So only remember some key aspects about the IPCC. The last report of IPCC just emphasized the problems that we will have if we go for the worst scenarios. And mainly it's that will affect globally. There will be extreme climate phenomena which are in the Mediterranean areas. We should be concerned about that, because the extreme events will just hit our country more and more frequently and more intensively. And then, so the key message is reducing the greenhouse gas emissions, okay? And there is a final objective in 2050 to reduce almost to 0, what is called the net zero emissions scenario, by just shifting from fossil fuels to renewable energy sources. But that has some issues, and the issues are related to the vision on how we could do that. If we could do putting renewables where they were fossil fuels, and that's okay, and we will continue to grow forever, or if that is not enough, or what problems has that approximation. Mainly, what I will speak about the solution will go in the direction of that theory or that vision that just aims for substituting fossil fuels for renewable energy sources and keeping the system as it was in the past. And so, but that raises a lot of questions, major questions like social acceptance of that deployment, but other minor questions, or I would say minor because it's not in the mainstream media. What are the ecological impacts for the ecosystems of that massive deployment of renewables? let's take a look. That is a figure that I like to show in its talk because it's very illustrative. So in the changes in CO2 concentration in the atmosphere in the past 45,000 years, and here we have in the Holocene, the last hundreds of years, we have that peak of emissions, not only in the quantity of CO2, but also in the velocity that we are putting that in the atmosphere. Okay, that just has some problems. But the other side of that is that what we do to manage that. That is the two figures from the United Nations Environmental Program, and that was the emissions gap, what it's called the emissions gap report in 2019. And here in your left side, you have the total emissions, and in the right side, you have the emissions per capita. And we will see here that it's very curious that because the main emitter is China, followed by US and Europe and then India. Here there is a thing, if we look at the picture, that it's strange because we have the emissions, the total emissions, but then we have in the discontinuous, in the dashed line, we have the consumption associated to that emissions. And we will see that, and we are seeing that here, China has less emissions if you just consider, you discount the emissions that are, should be accounted in other territories that they just, if we count as the emissions in absolute way. And look at China, look at India, and look at Europe, and look at US. So it is inverse. So the emissions that we emit for, so we delocalize the emissions, in fact, okay? But then that is more striking if you go to the right side, emissions per capita. Then the biggest emitters are US and are Europe, okay? So that means that we need to do more effort to decarbonize. So we need to pay more, okay? And we need to pay more for what we are just putting outside our frontiers, okay? So, associated to emissions and to greenhouse gases and the global warming, there is another part which is important, and you also already know, which is the ecological impact of our industrial civilization. That is an old paper. It's a 2012 paper, so it has 10 years. But it's nice because, and I like particularly because that is in physics is an hysteresis cycle, which means that it's a system, in a physical system, when you push that and you change the environmental conditions and the control variables of that system, so it can have abrupt changes. So in that graphic, it's very illustrative because here in the circles are in the dark green, the percentage of ecosystems that are affected irreversibly in the Earth. And in that paper, which was a review paper, they said that at the moment that the number of the ecosystems affected in that way that they, if you don't just stop to affecting them, they won't go back to the original state. If that crossed the 50% of the ecological systems affected, then there will be a critical transition to another unknown state, okay? And that is important because that will affect everything, because we humans are not robots, okay? And we need to eat something, but we eat something just collecting it from ecosystems. But there is another, there are another impacts. That is the well-known planetary boundaries, in which in a graphic and in a picture you could see the different variables that are affected by our activity or human activities. And we see here that we have crossed several thresholds on the planetary boundaries. And that in some of them we are almost there, for instance in ocean acidification and and other like some parts that are, some variables that are not included here. But the thing is that we are pushing so much pressure on the ecosystems. What are the impacts? So the impacts, it's the first and the most striking impact is that maybe the global food production will go down or will not be enough to feed all the people in the earth. And the other thing is that our agricultural system requires a lot of energy because it's far away from being just sustainable. And with the climate change, that will increase. The energy required for just collecting food will grow more and more. But associated to that also will be freshwater degradation and aquifer decline. And there is estimations that the requirements to increase the food and the energy production will be at 60%, and the requirements of water will be 20% more than now at the end of this century. So that puts big trouble in our society. So there is another crisis that it's almost unknown, but we just start to realize now by the Ukrainian and Russian war. But it's not only a matter of the effect of the war, because the global production of fossil fuels, it's going to a point where it will be impossible to grow more. And related to that, and just a little, I am going just for one teaser that we did in the pymedeas project, the European project that I have coordinated some years ago. And we make a video just to show what will be the energy crisis and how that could affect us. Okay? It's just 3 minutes.
There will be a day where things won't be as you know them.
On this 10th of May, another power outage has hit the city. Specifically this morning, the government has made another announcement in which they are restricting once more.
Hello? Emergency office.
Consumption.
A day when the warnings will stop being a game.
Remember that it's not permitted to use your household equipment during the next 24 hours in order to supply the required emergency services. Today has entered into force the restriction of energy consumption in your homes.
Due to many power outages,
There will be a day when your actions are no longer reversible.
to be able to supply our population with energy.
And when that day arrives, maybe it's too late.
The problem is the lack of transparency and information from the governments. We have never been warned of the real problem,
Dad,
or
can you
what
come
could
pick
be
me
the consequences of this situation.
Today, you have to make a decision. Be a part of the problem or the solution.
To be able to supply emergency services, please disconnect all appliances and devices you are using.
But now, tell me, will you ignore it when it knocks on your door? Do not allow an energy crisis. The future starts with you.
Okay, let's continue. So, energy crisis. That is a fiction, okay? It's a fiction that we did in 2019, okay? But it seems that it becomes more and more feasible. Okay. Why? If we look, if we look to what the International Energy Agency is telling us, International Energy Agency is the OECD organism. So it is an agency that advises the main developed countries on matter of the energy. And that is a figure that they show in the annual report that they do, which is called the World Energy Outlook at 2018. And they said, that is a figure that you can find in internet, that if there is no investment of the oil companies for upstream, which means that looking for new fields and developing the fields that are currently being developed, so putting more money for developing, there will be a sudden degrowth of the energy production, of the oil production in the world, global. And so that is a warning of the International Energy Agency to the states of the world to just manage what could happen if we don't deal with that fossil fuels just peak and try to go for another different energy sources. But it's difficult because here it's the percentage of fossil fuels that we use. That is a 2014 picture, but it's the same almost today. So what means that we need almost 80% of fossil fuels to run our society. And we need to move from that 80% to only hydro, wind and solar, and other marine renewables. But we need to do that fast, and we need to do that in this decade. So the challenge is huge. It's so huge that even the executive director of the International Energy Agency, it was last week, he was saying that related to the problem of the Ukrainian war and related to the problem of the gas needs and the gas production and the gas needs of the European countries, that could have tremendous consequences in the geopolitical arena. Because he said in the Financial Times, which is not a journal that is suspecting to be, let's say, revolutionary or something like that, that the energy crunch could have deep consequences in Europe and create a lot of problems internally. Okay. So it's a big issue. So what is doing the EU related to that? And not only EU, I will focus on EU in Europe because we are in Europe, but it's US is doing something that is similar. Okay, it is called the New Green Deal, and I think that most of you have heard about that. And so, but let me just go and have a step backwards and have more perspective. So the EU Green Deal just aims to have what we use and the processes that we need to fuel but fossil fuels. Instead of that, just shift to renewable energy sources and keep the system going as it was in the fossil fuel era. But that could be a big opportunity, but also could be what is called greenwashing. Okay, why? Because the aim is decarbonization, but the objective, the final aim, depends on the path that we do. So it's not the same that we go to zero emissions or to net zero emissions by shifting everything and converting everything to electric gadgets, but trying to change and make social changes. Because there is some literature that just points out and warns about that the energy transition could not be as just as is required. So could left behind some people that are mainly people that has not so much money. So for that, just aiming to the moon, it means that we need to look at the path. And it's not only the path will not be only to shift to renewable energy sources. That is keeping the eye in the finger. So, what aims the EU Green Deal? It aims for climate neutral Europe. That means zero net emissions in 2050 through a change in the economy, which is going for the circular economy, which is a very general concept, but there are things that couldn't be circular, like the energy. You use the energy, then that energy becomes degraded, and you cannot fit with that energy again in the system. Then it's a huge effort of building, reducing the pollution, and then just make new laws and regulations to protect the ecosystems, and then going healthier and greener in the strategy that they call from the farm to the fork. So in all food that you produce, in all the steps that you do in the production, you need to reduce CO2 emissions and reducing the ecosystem impacts. But here is another data, another quantity that we need to observe. In Europe, we waste the same amount of food that we import. That's circular economy? I don't think so. And at the moment, there are no ways to reducing that. And then they just aim for doing diplomatic efforts to take the lead for decarbonization in other countries outside Europe. And the European Commission is putting 1 trillion euros for that decade to make that decarbonization of the economy, shifting from fossil fuels to renewables. And it's divided in 1.6 trillion will be needed, and the total will be 2.6 trillion according to the European Commission. The point here is if you just take into account all the public money that the European Commission is putting on the table for doing that transition, it's 90 million only. The rest will come from attracting investors to go finally for that 2.6 million. But let's look if that is enough. If we go for the IPCC reports, they state that we need to invest 2.53% of the GDP for making that decarbonization of the economy. And then take the numbers. If you just translate that for the GDP of the European Union, that means that we need 342 billion euros per year for the EU to make that transition. But the problem is that European Green Deal aims to mobilize only 260 billions, and just counting that a big part of that will come from private investment. So here it's just an evidence that even that EU is just saying that the Commission is saying that it's doing a great effort to making the change, the effort is not enough. Because even in the financial investments, they are not enough regarding what the IPCC it's demanding. But IPCC is very conservative. If we go for looking for another evaluation of what is needed to make that transition, then we should, for instance, go for the models, and that are special models for doing that projections, taking into account the social aspects and the climate too. And one of them is a pymedeas model, which it's an integrated assessment model that it comes from the MEDEAS project, the European MEDEAS project, and has different modules regarding energy production, economy, society, environment, climate, and so on. With that model, you can make evaluations of what is the amount of GDP that you need for making the transition in some sort of scenarios. If you look at that, then you could see that in pymedeas, it is required for doing the transition of 5% of the GDP, not the 2.5%. But if you go for other authors, independent, they go for the 4% of the GDP. So that shows that it's telling us that the amount of money that, that we are investing in Europe to make the transition and to make the economy decarbonized, it's not enough, it's far from enough. One of the big parts, and what is the main emitters of the of CO2 or the greenhouse gases, is the transport. So we make some calculations, also that it's a work from pymedeas project, that what is the necessary investments to shift all the fleet that we have, vessels, airplanes, just cars, trucks, and so on, trains, and making them renewables, making them electric, okay? If we just count everything that we need in a global way, we did that for world and for Europe, the scenarios that we just designed, they tell us that we need between the 2.3 and 2.7 of the EU GDP, of the yearly EU GDP, over 30 years to make replace the fleet. So that goes farther and deeper than buying electric cars, okay? Because in that scenario, we also assume that the airplanes would need to be reduced by half. And also the vessels, I mean the marine traffic needs to be also reduced by half, because they are very intensive users of energy, and if they are not fueled by fossil fuels, then and replace that fuels by biofuels, then the energy that they will require will be, and the impact will be bigger. So going to renewables, then we need to just take a look on what is necessary to, supposing that we want to replace, to provide to the society the same amount of energy or the same power that we are using currently. It is more or less like it's around 12 terabytes, okay? But the problem with that is that the society needs what is useful energy, what it's the energy that can be directly used. So that means that it's final energy. But that final energy comes from fossil fuels now and from renewable energy sources in a small part, and needs to be transformed to the useful energy that we need in the society. That is called net energy. So if we look at the projections for the International Energy Agency, then in some of the reports, they just project the production, for instance, of oil. Okay? Here we have different curves. The black one is the crude oil that the International Energy Agency just projects, and it has happened, that the production of crude oil, so the best quality oil, it's degrowing. It's decreasing in time. And then there are the other types of oil. But look at the blue parts, which are the dark blue and blue. They are files to be found and files to be developed. And that part in 2040, it's the same that the production of the whole production of Arabia Saudita. So the International Energy Agency, it's telling us that we expect to have development and discovering new fields just to fulfill the gap between what is now and what will be, and that degrowth and decrease of the decay of the production. But that is gross energy. So it's the energy, the barrels that we extract per day from the fields all around the world. But then we need to make that from the energy that is useful to us. And if we do that, the energy doesn't grow anymore, because the energy that we need to extract oil in time will grow. So the final energy available that we will require will decrease in time. That is supposing that the energy that we require won't grow in time. So constant energy required for extracting the oil, which is not true, okay? Because like when you just, I mean, in an ecosystemic approach, the metabolism that you require for exploding, for instance, a field that is degraded, or a predator that that has prey and just take the prey in a rate that it's higher than the reproduction rate of the prey, just that has less and less prey over the time. So the energy that obtains from the prey, it's less and less as the time goes. So that is the same in that model. If we go for a linear degrowth of that energy need to extract the oil, we'll go at that figure of the left side. And if we have an exponential decay, we'll have that more optimistic part. So the question here is, if we degrowth and we have a decay or a decrease in the production of the energy, we'll need to substitute to fill the gap between what we don't have by renewables, okay? And that allows us to calculate what is the rate of development of renewables that we need to do only to substitute oil. That is not coal, not gas, only for oil. And then we make the calculations, and we have that for constant net energy, so we keep constant, so that means that it's that figure here, then we'll need rates of almost 6% of 2000 of implementation of, for the potential model, we will need a 6% of implementation at 2025 if we go for the linear model. If we go for the exponential model, the more smooth one, then we will need to around 1% of implementation. So that means that every year we need to implement 1% more of renewable energy sources that we did in the past year. Okay? If we need that the economy grows at 3%, which is that allows the system to not have an economic crisis, it's the right side figure. Then the implementation of renewables, it's like 8%, so between 5 and 8% per year. So that means that a growing economy put us in the scenario that is more demanding in terms of implementation of renewable energy sources. But there are other problems, and now I am going to the part of social and ecological impacts of that massive deployment of renewable energy sources. First, renewable energy sources has less energy density than fossil fuels. That means that for producing 1 watt of renewable energy, we need more area to obtain that watt of energy, of power, okay? So renewable energy sources requires more area, occupy more area than the fossil fuel plants, electric plants that we have now, or the nuclear plants that we have now. So, and we have some calculations in the pymedeas project. That calculation gives that for a world just running only in renewable energy sources implies 3 million square kilometers of occupation for renewable energy sources if we run all the current economy in renewable energy sources. That means the area almost of India. Okay. For Europe, if we just shift everything to renewable energy sources, that rough calculation, because that's very approximative, it's 6,000, 100,000 kilometers, square kilometers. That is more or less the area of Italy and Germany, Europe. okay? That can be reduced, that is a maximum, okay? Optimizing, making the system more efficient, but one way or another, we will need to occupy more area. And that means that we will affect, and we need to industrialize areas where now there are not industries. And that is an issue, okay? And that doesn't account for the supplementary infrastructure that we need to implement renewable energy sources, because we need to change the grid, the electric grid. We need to make more power stations. We need to make more interconnection in the European electric grid. And we need also more investment. And we need also change the technology, because now the electric grid is run in fossil fuels, and mainly what equilibrates the electric grid is the combined gas electric centrals, electric power stations. But renewable energy sources, they produce in the moment that we have wind and sun, but that doesn't coincide exactly when our society demands more energy. Okay, so we need to manage that, and we need to have some sort of demand management. But for the other side, the Commission just make what is called the Marine Strategy Framework Directives that aims to protect the EU marine ecosystems. How? Increasing the marine protected areas and making indicators to just tell us how good is an ecosystem, how wealthy is an ecosystem. So from one side, we need to occupy more area, and that includes marine areas. And for the other side, we need to protect that areas from industrialization. So there is a trade-off. And if we also plan to growth, then we'll need more and more areas to be occupied, because the needs of energy will be more and more, we will need more and more energy. So that is a problem. And there is a recent paper that I co-author with other researchers from here, from ICM, and also from University of Girona, that regards to the role and the impacts that could have the massive deployment of wind energy in the Mediterranean. Okay? Because the marine energy, mainly wind offshore energy in the Mediterranean will just be implemented in a new technology, which is not the same that has been developed and implemented in the North Sea. In the North Sea, we have fixed wind turbines, but here in the Mediterranean, because the depth of the water is higher, then we will need floating wind turbines. And that means that the turbines will be also bigger and higher. So we make some sort of tracking of what are the different variables regarding that Marine Framework Directive. And so we just choose 11 good environmental status descriptors. And here we have a list of that descriptors that what are the impacts on that descriptors of developing that big turbines in the Mediterranean Sea regarding the past experiences in the North Sea and the other areas of the world, but with a different technology. So one of them, it's biodiversity could be affected because the anchors that have the floating wind turbines could affect the anchors, and the change could affect the seabed. That could be because they have ballast water, and they will be also maintenance ships for that infrastructures that, of course, they will introduce non-indigenous species. Then there are some literature that they are just putting in the table, the fact that if you have wind farm, that area is not, there is not allowed to fish on there. So that could act as a reservoir, okay? So that could be a positive impact. Then also could be by introduction of non-indigenous species that could affect the food web by so introducing new communities. Regarding eutrophication, there are no studies. Regarding also the marine litter, there are no studies, and also for contaminants, there are no studies, or even though the generators and the accidents that could happen in the turbines, in the wind turbines, could affect and could pollute the marine ecosystems. There will be also a change in the hydrographic conditions because the wind mills will just change the wind field that is blowing over the sea, and that could affect the wind field and also the mixed layer, the ocean mixed layer in the wind farm place, but also downstream the wind farm. And also there will be impacts with electric cables that just evacuate the energy from the windmills to the land, and also related to the noise that make windmills in the sea, and also for birds and other impacts. So, to conclude, I will just focus more and give a little bit floor for questions. To conclude, the main conclusions are we have a strategy at the European level for the going to another energy sources, but we need to take into account also how we reach that objective. Maybe the means that only putting the money on the table, part of the money needed, and just allow the private investors take the part of that money and making the job, maybe it's not the best way, because that has the danger of lose control of what they are doing in an economic system that only looks for the immediate benefits. So maybe we should go be more humble and look at different strategies and just be more critical a little bit, just asking ourselves if we are doing the things and if we did the things correctly in the past, because the situation that we have now, it's due mainly because we have a socio-economic system that behaves as it behaves. So maybe it's now the time to think in another way to behaving, so changing some and have huge changes in the socio-economic systems. Besides that, we need to take into account that also the renewable energy sources have limits because they just require rare earths, materials that are not abundant in Earth. So that poses also limits of that huge development that we need. Okay, and there are also literature regarding that key aspect. And finally, we should learn from the ecosystems. We should learn that we are a part of the ecosystem, as Ramon Margalef suddenly just tell us. So if we are part of the system, of the ecosystem, we need to just go in another way and just go for be more resilient. That means that we would construct or change the socio-economy, the society, in a way that could just manage the perturbations in terms of climate extremes, in terms of climate change, I mean the increasing global temperature, but also in the terms of stopping the ecosystem degradation. So we need to prepare for unexpected issues that even the models and even our best estimations doesn't account for, in a global level, but more importantly, a local level. So that's all. Thank you very much.